Today we will briefing outline sequence impulse process technology focusing on oxygen injection with a stepwise design for blast furnaces. Now in this example we took a furnace with a 24 tuyeres and in a uh, one pulse pattern there will be coverage of 6 tuyeres out of 24 and like these this 6 2 year impulse pattern will keep on repeating for the entire cycle. So the SIP method pulses oxygen to 6 2 year at a time and each for just half a second at 20 bar pressure. The main components of the SIP uh, are many, but here in this slide we try to show that the pulse when will be executed 15,000 normal meter cube per hour oxygen will be pushed, whereas once the pulse is over, then a normal flow of oxygen will be there to cool the plants. Now coming to the main components of the SEEP, that is the inlet valve, pressure regulator, pulse control valves, flow meters, cooling valves, backup. All those components area wise has been segregated. Now if you talk about the scalability, as we can see that the furnace which is already where the CP is under execution 42 years or with 10,000 tons per day production and oxygen supply rates for these is calculated based on this basic information at 15,000 normal meter cube hour. A zero point 0.5 second pulse deliver about 2.08 normal meter cube oxygen per lance, and with this basic idea we can go further as this calculation shows on the basis of this information. Now as for the oxygen supply and ring main design involves a 20 bar oxygen network with a buffer vessel for the pulse stability and a robust ring main around the blast furnace for coverage of all 2 years. Coming to the SIP boxes, which are the main heart of the process, 2-year control units, each 2-year has its SIP box. For this example, if we took 24 2 years, then there will be 24 SIP box will be there. So this 24 SIP box metering and delivering programmable oxygen pulses above the 2-year deck for the precision, and their precision is very high. So as for the SIP injection lances are concerned, these are also one of the very important component of the SIP process, where as for this example 24 SIP lances custom designed for the supersonic pulsed oxygen injection, which ensure a long durability and a very reliable cyclic performances. Now, as for the dedicated SIP control system is concerned, a central programmable control panel schedule pulse timings, monitor operations, and offer flexibility in the pulse modulation. As far the nitrogen safety system is concerned, nitrogen line match oxygen flow for purging and cooling, automatically switching if oxygen is unavailable for the safety. So here nitrogen is also very important. Now coming to the um, basic oxygen and cooling system, there is a continuous flow of oxygen cooling in the lances, which cool the lances and also extend the life of the lances between the pulses with automatic switch to nitrogen in emergencies if any occur. And as for the SIP safety system features are concerned, these are the most important. And as for the system component specifications are there, 24 years key specification it contain 24 SIP boxes, 24 supersonic launches, 20 bar ring main, programmable control, and a rapid emergency venting system. Now, coming to the installation part, installation and operational flexibility is concerned. SIP boxes mount near tier for the fast responses. Each box has its own programmability, manual override, and fail-safe mode also. Now, as for the SIP launch and system integration is concerned, the all inserted lances insert lances through the blowpipe during the short outrages, and oxygen nitrogen ring mains installation is there, from where we have got a connection, and this connection tapping is given to a control panel, and where it is also integrated with the alarm, which are closely associated with the safety interlocks. Now, as for the testing, training, and commissioning is concerned, the pressure testing gradual SIP start, operator training, and pulse optimization. These all are very, very important, and in order to ensure safe and reliable commissioning, the execution of all above explained activities are to be done. Coming to the uh, summary part, SIP block diagram, where finally the SIP block diagram summarizes all system, oxygen ring main, pulse valves, lances, cooling, safety venting, and process sensors, and all are managed